Hello, everyone, and welcome to the latest IEEE 802 Tech Talk. Today, we're focusing on the coexistence of IEEE 802.11 and 5G. My name is Jennifer McLean, Senior Manager of Education Products with IEEE Educational Activities, and I will be helping to moderate today's event. IEEE is the world's largest technical professional organization dedicated to advancing technology for the benefit of humanity. Please note a few housekeeping items before we get started. At the bottom of your screen are engagement tools that are resizable and movable, so you can move them around to make the most out of your dashboard space. We highly encourage questions for today's panelists, and you can submit them through the Q&A widget on your screen or click the purple Q&A icon at the bottom of the screen, and we'll answer as many questions as time allows. If you click the green resources icon at the bottom of your screen, you'll find more information about IEEE 802 standards and past and future virtual events. Finally, the on-demand link for today's Tech Talk will be emailed to all registrants approximately 2 hours after we finish. And if you'd like to tweet about this event, please use the hashtag IEEELearn. Our panelists today are Dr. Andrew Miles and Dr. James Guild. Dr. Andrew Miles has been involved in international standards development for a variety of networking technologies since 1988. He has been with Cisco since 2001, where he is currently responsible for Wi-Fi standards strategy and standards coordination across Cisco more generally. For the last 20 years, he has mainly focused on the development of IEEE 802.11 standards and certifications as a participant, an editor, and a chair in various subgroups of 802 and the Wi-Fi Alliance. He is currently chair of the IEEE 802 JTC1 Standing Committee and the IEEE 802.11 Coexistence Standing Committee. Dr. James Guild joined General Atomics Aeronautical Systems in 2016 as a principal RF systems engineer and has been a contributor to international communication standards for 21 years, primarily in IEEE 802. He has held a variety of leadership positions in 802 and is currently the 802 LMSC Executive Committee First Vice Chair and the 802.15 Working Group Technical Editor. He has 28 years experience in a variety of areas, including radar absorbing materials, RFIC, RF system specification and architecture development, and MAC protocols. We'd like to welcome everybody, and I'll turn it over to James to get us started.
All right. Thanks, Jen. Thank you very much. But before we begin, I want to point out that any opinions we're expressing today are just us or the speakers and are not of the IEEE. So we want to make you clear on that. Just Andrew and I, our thoughts on this. And them certainly doesn't represent the views of our employers or anyone else, just ourselves. All right, Andrew, why don't you take it away and tell us what we're going to talk about today.
Okay, well, good morning. Let me start by apologizing for my voice. I actually went to a Wi-Fi Alliance meeting in Chicago 2 weeks ago and picked up COVID. And I will tell you, it's a nasty little disease. But that aside, today we're going to talk about coexistence, and in particular, how best to make the use of unlicensed spectrum, and I guess in complementary terms, licensed spectrum as well. So we're going to hear a story about the coexistence between Wi-Fi and the various LTE-based technologies, LTU, LAA, NRU, in unlicensed spectrum. And in today's terms, unlicensed spectrum is usually the 5 and 6 gigahertz band, although obviously the 2.4 band is the grandfather of unlicensed spectrum. On the way, we're going to talk about some of the coexistence discussions and debates over the years, and in particular highlighting some of the dangers of relying too much on claims based purely on simulations. Where today's talk can end up is a conclusion that expecting good coexistence between heterogeneous systems in unlicensed spectrum might not actually be the best approach. And actually, maybe a better approach is to really leverage the power of Wi-Fi and unlicensed and the power of the 3GPP-based technologies in NR, in particular new radio in licensed spectrum, integrating them together as part of the overall solution rather than trying to share the unlicensed spectrum in the way that some people have envisaged. Okay, so that's where we're going. So you sort of have the starting point and the ending point. Let's get into the middle. Find the right button here. Okay, so let's sort of look back in time a little bit. And it really wasn't that long ago that communications were actually pretty expensive, complicated, and actually often out of users' hands insofar as they were often very much in the control and the hands of their service providers. It wasn't so long ago. I remember making telephone calls to my grandparents in South Africa at Christmas, where we actually had to book a call ahead of time. But, you know, all sorts of technologies existed in the past, you know, telexes, fax machines, the early mobile phones, all very complicated, expensive, and, as I said, in the control of the service providers. Fortunately, things have changed. And a lot of those technologies of the past are now in the bin of time. And we've moved to a new world. And it's a new world which is very much sort of internet focused. It says World Wide Web, but actually really mean the internet here. And we are connecting to the internet using mainly two technologies. We're using 5G, 5G, using licensed spectrum, and we're using Wi-Fi, a little bit of fixed connections for the vast majority of connections to the internet using unlicensed spectrum. And in fact, 95% of traffic going on to or data traffic going on the internet today is actually through Wi-Fi. So that's our new world. Now, this revolution that led to 95% of traffic going through Wi-Fi, it all started way back in 1987 with the FCC when they tried something. They put forward an experiment that opened up the 2.4 gigahertz band, often known as the junk band, for unlicensed use. And what that did was it provided a mechanism for various technologies, unlicensed technologies, such as Wi-Fi and Bluetooth, to operate easily. And the real key here is that with unlicensed spectrum, particularly with Wi-Fi, but also the other technologies too, it allows anyone, anytime, anywhere to really easily set up a network and operate a cheap network that just works. Just works well enough, but it works in an increasingly diverse variety of devices and applications. And we see that today because, you know, it's not so long ago that, you know, Wi-Fi, for example, was used just really for laptop connected to the internet, for maybe email and a few other things, whereas today it's used for everything, including your dishwashers, my bathroom scales, which tell me I'm too heavy, as well as the traditional uses. This experiment started in the 2.4 band, but it continues. It's continued to the 5 gigahertz band from the early 2000s, and now we're heading into the 6 gigahertz band because the extra spectrum is needed to support these wide variety of uses. It's not just in the US where it started with the FCC, but it's spread globally. So just about anywhere in the world, you can have access to this unlicensed spectrum for all of these benefits. Now, I talked about the importance of unlicensed spectrum, and in particular Wi-Fi, which is really the dominant technology in unlicensed spectrum. And there are multiple dimensions to that, but two I can focus on really easily. One is the economic dimension. There was a study undertaken by the Wi-Fi Alliance a year or so ago. Okay, they're a little bit biased, but you know, they did get some independent advice. And the conclusion they came to was the global economic value of Wi-Fi, just Wi-Fi, in 2021 was $3.3 trillion. Not billion, trillion. It's a very, very large number. And the expectation is by 2025, it'll be up to $4.9 trillion. This is really important economically, unlicensed spectrum and therefore Wi-Fi. But it's not just that. It's also the social element of it. A few years ago, I was the chairman of the Wi-Fi Alliance, and at the time we did a few surveys, just fun surveys to find out what people thought about Wi-Fi. And, you know, in surveys even 15 years ago, people suggested they would rather give up their beer or their coffee rather than their Wi-Fi. Now, if that was true 15 years ago, I'm sure it's more true today. Okay, So the reality is this experiment by the FCC has been incredibly successful. It's real, it's huge, and it's undeniable. But that sort of leads us to an interesting question. Okay, so we've got this unlicensed spectrum. Anyone can use it. Why is it that we've got all these technologies working together in a licensed spectrum? They're all unmanaged. They're not necessarily coordinating with each other. Why don't we get coexistence chaos? Now, I think there are a number of different answers. I'm going to provide answers with a little bit of a Wi-Fi focus. The first thing is, actually, in reality, Wi-Fi doesn't really compete or coexist with the other technologies, particularly in the 2.4 band. Really, in the 2.4 band is where the most coexistence actually occurs. But if you look at technologies like Bluetooth or Zigbee, they generally try and avoid the Wi-Fi transmissions by operating either between the Wi-Fi channels or beyond the Wi-Fi channels. So it's not so much coexistence, but it's a little bit of avoidance. The second thing is that within the Wi-Fi world, because there's a lot of Wi-Fi on Wi-Fi coexistence going on, Wi-Fi has a whole multi-level series of mechanisms that are very much designed to enable pretty reasonable coexistence between independently managed Wi-Fi networks. So it really is possible for you to have an office building or an apartment building of users all operating completely independent Wi-Fi networks, and it actually works well enough. And the third aspect, I think, which has really avoided this chaos that was potentially going to be there, is very much a degree of self-interest. So if you look at the Wi-Fi Alliance and the IEEE 802.11 working group who is involved in the certification and the standards development, both of those organisations are representing stakeholders who have very much a vested interest in making sure that the coexistence that does occur, mainly between Wi-Fi and Wi-Fi, actually is pretty good, and particularly as the generations move forward. Okay. Now, I talked about the mechanisms that Wi-Fi uses to create this reasonable coexistence between independent networks. And that really comes down to a few things. And probably the most important aspect of it is a thing called CSMA-CA, collision sense multiple access with collision avoidance. And what it does is essentially a listen before talk with some sort of exponential backoff to sort of coordinate between the independent systems. And it enables fair access for limited periods of time. But that basic mechanism is supported by other aspects, both at the physical layer level and also at the MAC level. At the MAC level, there's a thing called NAV, or Network Allocation Vector, which allows at the MAC level to sort of reserve the channel across multiple transmissions. And this is actually particularly important for something called hidden station mitigation, using RTS-CTS, which is request to send, clear to send. So that also works pretty well, but also works with a couple of physical layer aspects. The first thing is that there's a very robust preamble in Wi-Fi, which essentially reserves the channel as busy for a frame length. But it's basically, if you receive a preamble above minus 82 dBm, you say, channel's busy, I'm not going to transmit, and because someone else is transmitting. And there's a backup mechanism based not just on the preamble, but based on pure energy, which operates at minus 62 dBm. All of these things together provide pretty good, fair coexistence between independent systems operating the same channel. But I will point out it's not perfect, because the fundamental problem here is that when we do this listen before talk, we're listening at the transmitter rather than at the place where the transmission might cause interference. So we do have very much a compromise. It's an effective compromise, but it actually works. Okay, so we've got this unlicensed spectrum. Wi-Fi is using it, really successful. Bluetooth and Zigbee and some other technologies are also using it, but they're avoiding Wi-Fi because Wi-Fi is the big guy in town. But the trouble is, well, not trouble is, one of the benefits of unlicensed spectrum is anybody can use it. Even though it's often called Wi-Fi spectrum, actually it's available for everybody. And if you look at the cellular stakeholders, they sort of looked on this and they said, look, we're paying lots and lots of money for licensed spectrum, and there's this unlicensed spectrum which is too valuable to give up, and it's free. It's really, really cheap. So over the last few years, there have been various quite legitimate initiatives to specify cellular-based technology alternatives to Wi-Fi in unlicensed spectrum. There was LTU from the LTU Forum, there was MultiFi from the MultiFi Alliance, and there are a series of technologies from 3GPP, including LAA, NRU. Now, of course, there's the usual marketing gump associated with these. Say these technologies are wonderful, and they're much better than anything ever done before in terms of performance, throughput, latency, and reliability, and integration with licensed technologies. We'll leave those discussions for another time. We'll focus today very much on the coexistence aspects. Okay, so let's look at LTU. Now, this LTU was a technology that was introduced by the LTU Forum in about 2015, so quite some time ago now, 7 years ago. And the goal at the time was to provide a fast way of getting the LTE technology into the unlicensed bands. This quickly led to controversy because the way of sharing the LTU was promoting was essentially the LTU system took what they thought they deserved and sort of gave the rest to Wi-Fi, which didn't go down very well with the Wi-Fi community, which was very much used to this distributed, shared mechanism using the LBT, where no one was actually particularly in charge. And, it got really controversial. The FCC was dragged into it. There were demands for testing and test plans, and they were put together under the auspices of the Wi-Fi Alliance, under the direction of the FCC. And it took so long to resolve that by the time it was all resolved, no one was particularly interested, and LTEU missed its market window and went away. So that coexistence mechanism and problem sort of went away just naturally. But then we moved on to some other technologies, and more recent versions came out of 3GPP. There was a technology called LAA, which stands for License Assisted Access, and that provides essentially use of the unlicensed spectrum for downlink access only. And there's also a technology called New Radio Unlicensed, which actually in many respects is very similar to Wi-Fi in terms of what it's trying to do and how it operates. Now, these two technologies are quite different from each other, LAA and NRU, in many respects, but they're also very similar in terms of basic access. Now, the good news is there was lots of debate about how LAA and NRU were going to access the medium. Was going to be sort of more LTE-like or more Wi-Fi-like. Ultimately, it was decided to use listen before talk with exponential backoff in a way which is very similar to Wi-Fi. So that was good news for coexistence. Although this was, lots of debate, and it's partially forced by some, activity that occurred in ETSI brand and the European rules. But that was all good. The problem was the way they chose to listen was a little bit different. And they decided to use energy detection only rather than that sort of multi-level MAC and PHY mechanism that Wi-Fi used. And so the open question now in terms of coexistence, because we've got this LAA and NRU technology potentially coming down the track and competing with Wi-Fi, is whether those mechanisms that they've got, including the energy detection only, provide and encourage good coexistence between LAA, NRU, and Wi-Fi or not. Now, if you look at the extensive simulations in 3GPP, the answer would be yes. If you look at the extensive discussion that occurred under the auspices of ETSI brand, again, the answer is yes. But the question is yes really the answer? Okay.
I suppose you're going to tell us about this.
I am indeed. Okay, so one way, we've had a lot of discussions, we had lots of simulations, and what they do show is that there is reasonable coexistence between LAA and Wi-Fi, and that should be good. But actually, simulations and discussions aren't really that important. What's really important is real deployments. And fortunately, there has been a little bit of work in measuring real deployments. The University of Chicago did some work during 2020 and 2021 looking at some early deployments in Chicago. And what they showed is that under the various deployment scenarios on the test, LAA has a significant adverse impact on Wi-Fi operation. So we may actually have a coexistence problem. So this is just one of the examples of the measurements that they did. This happened to be 5 access points and 5 clients, or 5 access point client pairs talking to each other, doing various things, data plus voice, streaming, data plus streaming and video. You'll notice with the 5 clients, they're all getting about 3 megabits per second, except for the one on the right, which happened to be an older technology. And that was sort of, I guess, what people expect to get that sort of throughput. And there was no LAA operating in this particular scenario. And then LAA was turned on. And what happened? Oh, the Wi-Fi traffic collapsed. Now, interestingly, the traffic in, I guess you call it a yellow, didn't collapse, but it turned out that didn't collapse because that traffic was being sent on the licensed, in the licensed spectrum. So it does appear that, at least in real deployment scenarios, despite all the simulations and despite all the discussion, we may still have a problem. Which leads me to a bit of an aside that I sort of alluded to in the introduction. This thing about simulation. Now, we had lots of simulations in 3GPP and XE-brand and even in IEEE that proved good, acceptable, or bad coexistence in various scenarios. But I think what we've learned from all of that is that we should treat simulations very much with a degree of caution, because proving good coexistence is actually quite hard. And some of the problems we've run across is that, with these simulations, there's often poor emulation of the environment and the complexities of real environments, particularly with radio. That's really complicated. Often there are inaccurate models of systems, particularly because people try and sort of emulate systems which haven't actually been designed yet in the future. There are many examples where simulations have been used to show things, but really what they've shown is what the person designing the simulation wanted them to show. You get what you design, and it's really amusing when you often get the same data being used by 2 sets of people to prove completely the opposite conclusions. And I think the other thing is that when we use simulations to prove things like this, we hide a lot of the complexity behind averages. And as I was pointing out to my fellow speakers earlier today, when I play golf, often I hit the ball, I slice it to the right, or I hook it to the left, which on average makes me a great golfer. And yet I'm not a great golfer, I assure you of that. Now, that all said, I will say that simulations do have a place in understanding coexistence. They certainly provide insights into some of the coexistence problems, and they provide insights into some of the possible solutions. And they're also really good at proving things don't work. So that's just a bit of an aside about simulations, which is because I've found simulations, their use and misuse has been slightly annoying during this whole debate. So let's get back to why we may still have a coexistence problem. Well, the good news is, as I said, all these technologies are using listen before talk with exponential backup. So that's really good. There's a homogeneity there. And in terms of LAA NRU, the other good thing is they are using listening. And in this particular case, they use listening with energy detection only. And actually, they use a lower threshold. They use minus 72 rather than minus 62. The problem we've got is we've got this heterogeneous behavior insofar as the LAA NRU don't pay attention to the preambles down to minus 82 dBm, like Wi-Fi does. And probably more importantly, and the source of many of the problems we found in the Chicago deployment measurements is because the LAA NRU don't operate the Wi-Fi MAC, they can't use the nav, and therefore they can't do the hidden station mitigation mechanisms. So we seem to have this problem based on the heterogeneous use of technology. Okay, so do we still have a problem with LAA? Well, who knows? LAA has been around for a while. There's been lots of talk about it. But if you look at the deployment of LAA, it's been pretty flat the last few years. The number of service providers around the world that have actually deployed it has remained at 9 for over 2 years. And that doesn't even give an insight into how big those deployments are. So one of the possibilities is that maybe we don't have a problem with LAA Wi-Fi coexistence because LAA is going to go away. Now, that said, I will point out the number of devices supporting LAA is still increasing. And that leaves us with what happens next. Because let's suppose LTE goes away, which it has, and LAA, let's assume for the moment LAA is going to go away. That leaves us with NRU and Wi-Fi coexistence. We've done all the simulations, or we've done some simulations and lots of hand-waving. We haven't done any measurements of real deployments because there aren't that many, or if we don't know of any NRU commercial deployments yet. But we do have a question about what happens next because this coexistence is really important. We don't want to make a mess of the unlicensed spectrum. It's been too valuable to us economically, socially, and all other reasons as well. At this point, there are probably a couple of major options. One of the options is, well, NRU does deploy at scale, in which case we're going to have to keep working hard on how to deal with this coexistence issue. And I'd say that's probably where we are going in terms of the default option at this point in time. There is another option, and that is that NRU doesn't really deploy. And in that case, we can all breathe a sigh of relief and get on with integrating Wi-Fi in unlicensed and 5 and 6G in unlicensed. Let me go one level deeper on that first option. As I noted, I think that if NRU does deploy at scale, we almost certainly have a serious problem in terms of coexistence. And it's derived from the fact that NRU doesn't have the same multi-level coexistence mechanisms that have been refined and proven by Wi-Fi over the last 30 years, pointing out the Wi-Fi mechanisms are not perfect, but they are pretty good. And what that does is it's going to put the ongoing success of unlicensed spectrum somewhat at risk. Now, if this happens to be the way we go, it's certainly one of the pathways that we could go down. We're certainly going to have to put a lot more work into understanding and mitigating the coexistence issues that are going to arise in these heterogeneous environments, heterogeneous with people using different listening mechanisms and different MAC level mechanisms. It's not yet clear what needs to be done. And it's also not clear whether any solution is going to be based on cooperation between the various stakeholders, or the worst scenario would be a fight to the death. So I would argue, and this is my bottom line, is that Wi-Fi unlicensed plus NRU unlicensed is actually a risk to all the economic and the social benefits we've seen from unlicensed spectrum over the last 10, 20, 30 years. Option 2. This is where NRU really doesn't deploy in any scale. And, we reckon that, I guess this might occur because there's a recognition that Wi-Fi actually makes pretty good use of unlicensed spectrum based on that multi-level coexistence that they've built in from the beginning it works. And the fact that NRU hasn't adopted those similar mechanisms, and there is that risk of damaging the global and economic and social impact. Now, if we go down this path, it sort of says what we should really be doing, rather than trying to get coexistence occurring in the unlicensed spectrum, we should get coexistence occurring almost at a higher level, recognizing that Wi-Fi does a great job at using unlicensed spectrum, making a recognition that new radio does an awesome job in making the best use of licensed spectrum, and together, in a complementary basis, we can get Wi-Fi and NRU working together to provide communications across both licensed and unlicensed to get the best of both worlds. And so the bottom line for me here is Wi-Fi unlicensed plus NR licensed equals a likely benefit to humanity. And I use that term because one of the logos, or one of the sayings from the IEEE, is the goal here is to provide a benefit to humanity. Okay, so just an aside before I finish. A few years ago, I actually went to a few 3GPP meetings. And what I noted was the differences in culture and process and the ways of doing things, that it wasn't just about the protocols, it was also at a higher layer. And on the first day, or before the first day, I was staying in a different hotel, and I wandered across to the conference hotel to sort of see where it was. Walked into the main meeting room, and I discovered that every single seat in the room had been reserved for the week. And it occurred to me this is very much aligned with the scheduled philosophy of the 3GPP licensed technologies. In contrast, in 802.11 working group, we get to reserve the seat for the time we're actually sitting in it. A little bit like the .11 protocol. On the other side of the slide here, I also happened to go to quite a few meetings. I noticed that everyone would rush to the front to talk to the chair. And it appeared that certainly in many of the groups in 3GPP, the chair was very much a technical decision maker rather than the process facilitator. Again, very much aligned with the centralized control philosophy of the 3GPP-based technologies. In contrast, in .11, the chairs tend to play much more a coordinating role than a technical role. Again, that distributed control, very much like the .11 protocol. Now, I'm not saying that either approach, either in terms of process or technology, is better or worse. What I would note is they are very, very different, and it's difficult to get them to come together. And so a bit like the coexistence problem, when you have heterogeneous ways of trying to share, when you have two organizations trying to do things differently, it doesn't necessarily work together. And I think that one of the lessons that we're going to have to, that I draw from all of this discussion over many years, is that we really do need to get the best out of coexistence in our licensed spectrum. We do, at that lowest level, need to get a homogeneous approach to sharing, which is effective. Now, all of this leads me to a conclusion, and the conclusion is that, for me, the best way to solve coexistence in a licensed spectrum is to have good coexistence between similar systems, homogeneous at that access level, and let's not attempt the extraordinarily difficult feat of achieving good coexistence between heterogeneous systems such as NAU and Wi-Fi. But look, we're not there yet. The coexistence problem is still ongoing. It's not solved. There are other elements of it too. We've got to make coexistence between proposals for narrowband frequency hopping coexistence. There's the question of low power indoors versus standard power coex in 6 gigahertz. There's questions about ultra wideband coexistence, as well as the ongoing questions about coexistence between Wi-Fi and NAU. So if you're interested in any of these topics, please participate in the activities, and I'd particularly focus on the IEEE 802.11 Coexistence Standing Committee, where I'm the chair, and anyone, whatever your view, is very welcome to come and provide input into that process. And just one last comment before I finish. I will note that this coexistence topic does not exist in a vacuum. It's actually associated with many other issues as well, and I'll just focus on one of them at the moment, and that is the issue of new unlicensed spectrum. And there's a bit of debate going on about the 6 gigahertz spectrum. In the US, for example, the whole 6 gigahertz band has been allocated as unlicensed. In other parts of the world, none of it has. But in lots of parts of the world, there's a debate. Maybe half should be licensed and half should be unlicensed. Now, today, I've made a claim that actually Wi-Fi should be essentially the main unlicensed spectrum. And some people have argued, well, that's true. We should give in our technologies more licensed spectrum. And I don't think that's a conclusion you can draw. And this is sort of part of the interactions between different issues. I'll actually claim that all of the 6 gigahertz bands should be specified unlicensed. And the reason, I'm going to use Europe as an example. If you look at Europe today, roughly half the spectrum is unlicensed, and roughly half the spectrum is unlicensed. There's about 1,000 megahertz in low mid-band for licensed operation, and there's about 1,000 megahertz for unlicensed operation, excluding the upper 6. But the key is, and I'm using the numbers from Germany, is that the licensed spectrum only delivers about 5% of data traffic, despite having half the spectrum. And what that tells me is that clearly, if we're allocating spectrum, we need more spectrum for unlicensed rather than licensed. And it's not because there's any problem with license. License is really valuable. It's really important, particularly in the wide area. But what the mismatch in traffic does highlight the flexibility of Wi-Fi to deliver anyone, anytime, anywhere. And on that note, I've yabbered on for way too long, and I have no idea whether there are any questions or not. James, do you want to sort of lead the...
Yeah, I'll read off the questions we have. One quick question is there sort of an overlap between 802.11 working group members and also those who attend 3GPP?
Sometimes. They have, look, I will say that mostly it's very different groups of people, because to attend both, you'd spend your whole time on an aeroplane. And also, I think the other problem is, and I alluded to this, is they are quite different organisations, and it's quite difficult to operate in both. So there's probably not enough overlap, and there hasn't been enough communication. Mm-hmm. There has been some.
Okay. So, and as you mentioned, how Wi-Fi from the very early times had coexistence built into it. Is that because of things like the apartment problem, where every apartment has their own Wi-Fi link?
So certainly, if you think about unlicensed spectrum, you have to deal with the guy next door. Whether it's next door in the apartment or whether it's next door in the neighbouring office, there are a huge number of anyone can set up a network, and so that has to be the fundamental design consideration. And Wi-Fi dealt with that from the very beginning. Sometimes well, sometimes not so well, but we've learnt over the years what really does work. It's interesting. The original Wi-Fi had two main forms of communication. One was the EDCA-based, CSMA-CA-based scheme I talked about, listen before talk. There was also another scheme called PCF, Point Coordination Function. And that was very much where there was a centralized controller, and he said, you go, you go, you go, you go. That actually didn't work, and it didn't go anywhere. And there was an attempt to replace it with something called HCCA, which is a similar sort of centralized control, and that didn't work either. And we kept falling back to the basic listen before talk, EDCA, or so we call EDCA or CSMA-CA. That is what has worked continually over the last 30 years.
And that's based on people deploying these things and seeing how they actually work. It wasn't just, we did a lot of talking and it looked really good in the presentations, but sort of what ended up using is what we built and saw working, right?
Exactly. I think that's sort of, your comment highlights something which is really important. We can talk about it, we can simulate it, we can, theorize about it, but what's really important is how it works in practice, which is why I think it's now time to start looking at the deployment measurements about coexistence between Wi-Fi and some of the other technologies, rather than going back to the simulations or the analysis.
All right. Andrew, you mentioned these slides are publicly available. Where can people find them? I think Jen needs to answer that. Is that right?
Yes, we'll make them available to attendees here. Yeah, they're available. We'll make them available, and then Andrew also mentioned they're publicly available.
They are publicly available in the IEEE 802.11 working group document repository, which anyone can access. It's a public site.
Yeah. There's a question, do you think upstream scheduling with 11AX could match Wi-Fi to the latency requirements?
Right, so it's interesting. Wi-Fi technology, it has continually evolved over the years. And what I've talked about in terms of listen before talk with the exponential backoff is all about the basic access mechanisms. Within that, once you get access to the medium, you've now got control of the medium for a short period of time. Within that, you can do all sorts of interesting scheduling. And so what Wi-Fi has done in terms of technology is they've continually looked for that compromise between anyone can access it, but still getting that low latency and the low jitter. And the reality today is with Wi-Fi, you can get, latencies down to a millisecond relatively easily. And certainly, there are different types of environments. So, for example, if you're in a factory environment, the advantage of a factory environment, although it's unlicensed spectrum, you're able to control it more. And so, therefore, you can get even lower latencies. Whereas, look, if you're in an apartment building with 1,000 different networks, it might be a little bit harder. But even so, with what we've currently got, the reality is you can run your Netflix, you can do your IoT things that you typically want to do in a home environment. So it's basically a whole series of compromises that we've learned to find the right path over 30 years that actually work.
Right. So I know there's another question about downloading the slides and also about when our next meeting is. I think one web address for everybody is www.IEEE802.org. That will list our next meeting. And our next meeting, do you want to say where that is? Assuming you get to go, you may be too sick.
Well, the next meeting is in July in Montreal. It's actually a hybrid meeting. So you can attend either face-to-face, which may be dangerous, or you can attend remotely, which you still have to pay some money to register, and it's quite a reasonable sum of money, but anybody can attend from anywhere around the world.
Right. And from that site, there should be a link somewhere for the document server, which is mentor.IEEE.org, MENTOR. And from there, you can find the 802's web pages and 11 and search for this.
Yeah, absolutely.
Any other questions? I'm not seeing anything in the box. Did I miss any, Jen?
Nope, I think that's all of them.
Well, okay. Hopefully people through my comments today will recognize that I'm passionate about the advantages of unlicensed spectrum. I'm a little bit biased. I think that Wi-Fi is the answer. But regardless, we do need to solve any of the coexistence problems that come up. And so I think we need to all do it together. And whether that's in 3GPP or in IEEE or in the Wi-Fi Alliance, it doesn't matter. Let's make it happen.
All right. Thanks. And I want to thank everybody for attending this Tech Talk.
Yep, thank you very much, Andrew, for such a great discussion and presentation, and James for moderating. As we mentioned, the on-demand link for today's event will be sent out to all registrants in about 2 hours. And if you could complete our feedback survey at the bottom of your screen before you leave, we'd appreciate it. And thank you all very much for your time, and have a great day.
Thank you.
Thank you.